recursive sequences look a little more intimidating, I think, than explicit sequences, but when you break them down, they're not that bad. In order to solve a recursive sequence, you need to be given the first value, which we call a sub 1, and it also is imperative that you understand, what's the common ratio or the common difference. So we can break this down very similar to the way we broke down the explicit formulas. I want to pay attention here. A sub 1 is huge because that gives us the first term. Okay. But equally important is this part right here. You can see we've got 5 times a sub n minus 1. Now that looks a little confusing, okay? But all that's saying is, set that up. That's saying 5 times the previous term. Okay, that's all that's saying. Okay. So let me highlight. Okay, there's where we're getting the 5 from. And that a sub n minus 1, that's saying, well, actually it's not saying times, it's saying the previous term. There we go. So that's all that's saying. So, and if we're given the first term, then we know that we just have to start out 1 times 5, and then 5 times 5, 25 times 5, and so on. So let's show how we would do this in using this sequence. We got a sub n, so a sub 2 is what we're looking for. So that's going to be 5 times the previous term. Now the previous term of a sub 2 is a sub 1. Do we know what a sub 1 is? Yes, we do. It's right here. So to find a sub 2, we have to do 5 times 1. So a sub 2 is 5 times 1, or which is 5. It's 5. Okay. Now we need to get a sub 3. So a sub 3 is 5 times the previous term. The previous term from a sub 3 would be a sub 2. Do we know what a sub 2 is? Yes, we do. It's right there. It's 5. So I just have to plug that in. So now a sub 3 equals 5 times 5. A sub 3 is 25. All right, now let's go to the value that we want, which is a sub 4. So a sub 4, that's going to be 5 times the previous value, and the previous value from a sub 4 is a sub 3. Do we know what a sub 3 is? Yes, yes we do. It's 25, says it right there. So to find a sub 4, I'm going to do 5 times 25. Oops. Doesn't want to make that 5 there. Then a sub 4, 5 times 25 is 125, and that is our solution to this problem. We got it right there. 125. Here's the second one. They want us to find a sub 6, or the 6th term. And let's just break this down. This means 3 times the previous term. So let's get that language out. 3 times the previous term. Okay. So the 3 obviously comes from the 3, and the previous term comes from the a sub n minus 1. That's what that's saying. So we have a sub 1 is 4. A sub 2 is 3 times a sub 1, which is the previous term. Do we know what that is? Heck yes. It's 4. So we just have to multiply that by 4. So a sub 2 equals 3 times 4. A sub 2 therefore is 12. Alright, now let's do a sub 3. A sub 3, that would be 3 times a sub 2. Do we know what a sub 2 is? Yep, it's right here. It's 12. Oops, I didn't want yellow for that. I want an orange. Come on now. Okay, there we go. Orange, there we go. That's a sub 2. So now I just have to plug this in. A sub 3 equals 3 times 12. So a sub 3 is going to be 36. All right. Now let's do a sub 4. A sub 4 equals 3 times a sub 3. A sub 3 is 36. We already noted that. It's right here. So a sub 4 we will get by doing 3 times 36, which I have the math teacher brain, so I know that's 108. Kind of helps. And then the last one here. No, actually, we gotta go to 6. So this is not the last one. It's going to be 3 times a sub 4. And a sub 4, do we know what that was? Of course we do. A sub 4 was 108. So we will plug that in for a sub 4 here, 108. And a sub 5 is 324. All right, now finally, a sub 6 equals 3 times a sub 5. And do we know what a sub 5 is? Yes, it's 324. So I'll plug that in there. So a sub 6 equals 3 times 324. A sub 6. Okay, that's, let's see, 972. 972. So the value of a sub 6, or the 6th term in this recursive sequence, is 972. Okay, please try this one on your own. I will be back in just a moment with the solution. Okay, you're starting with 9 and then you're multiplying by 4 each time, and the 5th term, a sub 5, is 2,304.